I have an extensive collection of Heathkit products, but not any that would be considered a computer, so it was my hope to eventually acquire and restore at least one Heathkit computer. My preferred model was the H89. The older H8 is also interesting, but is larger and requires a serial terminal, and the H11 is also large and quite rare. Later computers that only ran CP/M, DOS, or Windows were too similar to modern PCs to be that interesting to me. The H89, similar to the H8 and H19 terminal, but contained in one case, was the sweet spot in my opinion. It can run Heathkit's HDOS, CP/M, and other operating systems, and there's a large collection of software written for it and an active community of users. My best option for finding a unit was eBay, but prices tend to be high, and many sellers will not ship to Canada. In April of 2024, I successfully bid on an H89, making it the 100th Heathkit in my collection. It was listed as Vintage Heathkit H89 Zenith Z90 Personal Computer Power Tested. While it said H89 on the front, the product sticker on the back said H88, making me suspect it was an H88 that had later been upgraded to an H89. It had 2 floppy drives, and in the picture I could see that there was some display on the screen, although it looked incomplete and garbled. The seller was a company called E-Asset Solutions, LLC, in Falls Church, Virginia, so presumably this was an estate sale. There were some delays in shipping. It went first to an eBay distribution center in Illinois and was shipped from there to me in Canada. It finally arrived on my doorstep just over 3 weeks after I won the auction. I was concerned about the unit being damaged in shipping. The Heathkit H89 is very heavy and contains a fragile CRT, or picture tube. It's very common for units to arrive with the CRT, which is hard to replace, broken. Ideally, you would want to pick the item up, but this is usually not possible. The best practice for shipping is double boxing. Pack the unit in a box with lots of packing material, and then pack that in another box with additional material. My unit was dropped off by a courier, and literally dropped off, as I think I saw the delivery person drop it to the ground. Initial inspection showed that it was not too well packed, but it was intact, and the CRT looked physically undamaged. However, 2 of the plastic CRT mounts on the case had broken off, and the CRT was pushed in a little. Hopefully the CRT was still good and I could glue back the plastic mounts. All in all, it could have been worse. Looking inside, I could see that in addition to the power supply, video, terminal, logic, and CPU boards, that the unit had 3 cards installed: a floppy controller board, a serial parallel I/O board, and a non-Heathkit board that I couldn't immediately identify. The CPU board also had a memory expansion card. There were, as expected, 2 5¼ floppy drives. It came with no manuals, software, or documentation, but some information was written inside the unit that gave me some clues to the previous owner. Inside the top of the case is written a name, address, and telephone number. This was consistent with being an estate sale in the Virginia area. I did a quick check of obituaries for that name and found a few possibilities, but none that were definitive. In my experience, it can be several years from the time someone passes away and estate items are sold. More notes, literally written on the insides of the computer, gave more information about its history. 9/22/80, CRT filaments out, horizontal jumpy, problem with TLB. 7/14/81, CRT died, no signal from TLB, no filaments, video board horizontal section, down 3 weeks. 11/10/81, CRT dead, horizontal vertical okay, cap on 555, second, bad. And written on the side of the floppy drives, purchased 22 October 83 at FD Services ChugCon. ChugCon was the international conference of the Capitol Heath Users Group. It was held a few times in the 1980s in the DC area. Written on the inside of the floppy drives under the shield was built 16 September 1980, plus 16K 18 September 1980, plus 16K 19 September 1980, plus 16K 25 August 83, H77 1 March 81, K Davis, H24 serial I/O and 810 printer 1 March 81. And written on top of the floppy drives, built 16 September 80, plus 16K 16 September, plus 16K September, plus 16K August 83, H77 dual 5 1/4 3181 from K Davis Estate, Serial IO and 810 added 3181, also from KD, Housemaster IO November 81, MTR 89 November 82, U562 74 LS 132 replaced with 74 L 132 13 August 83, 2 ET2 SA 465 20 October 83. And underneath the above, Housemaster IO November 1982, MTR 89 November 1982, U562 74 LS 132 replaced with 74 S 132 13 August 83, 64K total, 2 ET half-height dual drives 22 October 83, and the slots were marked cassette, crossed out with Housemaster, Serial, and Floppy. Written on the keyboard with a Dymo label was 3-disc config, no pull-ups in SY0. From the above, I gleaned that the summary of the computer's history was that it likely had one owner. It was originally a cassette-based H88 built in September of 1980. Within the first month, he added more memory, likely after finding out that running useful programs required more RAM. He had some issues with the CRT that continued over the course of more than a year, with the CRT replaced at least twice. About a year after purchase, it was upgraded to an H89, and the cassette interface was removed and an H77 floppy controller installed. This was likely an upgrade kit, which included power supply upgrades and a new H89 sticker for the front. At the same time, a serial parallel card was added. The upgrade was apparently from the K Davis estate, so maybe it was not purchased new from Heathkit. A Housemaster board, whatever that is, was added in November of 1981. 2 floppy drives were purchased at a Heathkit Users Group conference in October of 1983. The sticker that referenced SY0 implied that he ran HDOS, which uses that drive naming convention. I also suspect that the unit had a third drive that was external, as there were no terminating resistors on the internal drives, and a sticker read 3-disc config. The rear panel has a connector for the third drive supported by the controller card. Nothing was done after 1983. Presumably the system was used for some time, but eventually was considered obsolete, and the owner set it aside. I wonder if the former owner thought that someday someone would get his system up and running again. When getting a computer like this, the urge is to power it up right away and see if it works. But this runs the risk of causing damage if there are issues, particularly related to the power supply. I really wanted to know if the CRT was still good, but I resisted the urge and instead first performed the power supply and other checks described in the Heathkit manuals, rather than just powering it up. I initially did some inspection and light cleaning. I identified the boards inside and took a lot of pictures that might be useful later when it was disassembled. I removed, cleaned, and tested the fan. It runs on 120 volts AC. It was not very dusty, although it was quite loud. While I didn't do this right away, I removed and cleaned all the keyboard keys with soap and water. There were 3 small loudspeakers loose in the case. 2 were for the Housemaster board, described later. The third was for the computer itself and was put back in place with new double-sided tape. As mentioned, it's good practice to test the power supply before initially powering up and possibly damaging the rest of the unit. I performed the power supply resistance and voltage checks outlined in the manual, and they all looked good. Sometime later, the power supply started acting intermittent and then failed entirely. Investigation showed that the main bridge rectifier had failed. I found a similar part in my junk box that fit, and that solved the issue. The power supply uses linear regulators which get quite hot, and the fan mounted just above them is needed to keep them cool. Part of the H88 to H89 upgrade is to replace some of the regulators and add heat sinks as the floppy drives draw more power. Some H89 users have replaced the linear regulators with modern switching versions, which are much more efficient and run cooler. There are switching regulators which can directly replace the linear regulators. I ordered some buck regulator modules from Pololu, both 5V and 12V versions. I soldered on long leads and bent them so that they could plug into the sockets for the existing regulators and avoid making any changes that couldn't be reverted to original. Note that you can also get bug regulators in packages that match the original linear regulators, but I wasn't able to find a source that would ship to Canada at a reasonable price. I installed 2 5V and 1 12V buck regulator. With these changes, the system runs much cooler. The bridge rectifier also doesn't get very warm, and other power supply components like the transformer will be less stressed. The original AC fan is very loud. Even with the switching regulators and the power supply, there are still linear regulators on the TLB and CPU boards and some other parts that can get warm, especially when the case is on, so I felt that some cooling was still needed. I replaced the original fan with a quieter 12V DC fan, but I'm running it at 5V so that it's virtually silent, but still provides some airflow. Some temperature measurements indicated that this was adequate. One final change to the power supply was made that was recommended by other H89 users on the Discord channel. You should remove the 2 orange wires connecting the bridge rectifier to the power supply board, then remove the 2 yellow wires from the back connector and solder them directly to the bridge rectifier. It's also good to reflow all of the solder joints on the bottom of the power supply board. Apparently this was a factory authorized mod that greatly improves the reliability of the power supply. With the power supply checked out, it was time to examine the rest of the system, starting with the terminal logic board, or TLB. The board is part number 85-2376-2 and has manufacturing date stamps from May and June of 1980. One socket at U423 was not populated, and this is normal, as it's a socket for a ROM that's normally not used. I reviewed and checked that the dip switch settings looked correct. The board looked clean, so I powered it up in local mode, where keyboard input should be echoed to the screen. The good news was that it produced a beep, indicating that it came up and passed its self-test, and video was displayed on the screen, so the CRT was good. The bad news was that some of the screen was corrupted. Typing characters in local mode, not all positions on the screen showed correctly. I suspected bad video RAM, but I first checked some other things. Note that you can remove the CPU card and plug its power cable into the TLB board and it will operate, making it much easier to work on it. The power supply voltages and filtering looked okay. I removed each IC and cleaned the pins with a soft eraser and applied contact cleaner. I then tested most of the ICs with my Tontec IC tester. Some devices like the 2114 RAM chips couldn't be checked with the tester. Those that I could test were good. I started swapping some of the RAM chips to see if the behavior changed. I found that it did when I swapped the video RAM chips. I found that I had some spare 2114 RAM chips from another project. Swapping the video RAM with good ones indicated that one of the original video RAM chips was bad. Once replaced, the video was correct at all screen locations. The TLB uses tantalum capacitors, which are prone to failure due to age, and because Heathkit used some of the devices close to their maximum voltage rating. Most have a 20V maximum rating, and the ones ahead of the voltage regulators see about 18 volts or more applied to them. I've measured as high as 19.8 volts, depending on the AC line voltage. Tantalum caps have some advantages over electrolytics, such as smaller size, but they have a bad habit of failing and shorting if their maximum voltage is exceeded. When that happens, they can damage more circuitry and even burn the circuit boards. There are different schools of thought on whether to replace them. Some people replace all of them, while others say to leave them if they haven't failed after all these years. My thinking is somewhere in the middle. Just replace the parts that are close to having the voltage rating exceeded, using new parts with a 35V rather than 20V rating. I did this for the relevant 2.2 microfarad and 4.7 microfarad caps on the TLB board, 4 of them. That completed work on the TLB. The CPU board is Heathkit part number 85-2208-1. It looked good on inspection. It's fully populated with 48K of RAM, as well as having a third-party 16K RAM expansion card added, bringing the total RAM to 64K. It came with the MTR89 version ROM monitor, which I described in an earlier video in this series. I reviewed and checked that the dip switch settings look correct. Powering up the system in non-local mode, I heard two beeps indicating that the TLB and CPU cards passed self-test and got an H: prompt on the screen, a good sign. I tried several of the monitor commands and they worked as expected. I ran the ROM-based memory tests as outlined in the Heathkit manual, and all the tests passed. As with the TLB, I replaced some of the tantalum caps on the board, 3 of them which come before the regulators and run close to the 20-volt maximum voltage rating. The new ones are rated at 35 volts. As I mentioned in an earlier video, sometime later I upgraded the monitor ROM from the MTR89 to the MTR90 version, which involved burning a new 2732 EEPROM, replacing the secondary address decoder ROM, and adding some jumper wires to accommodate the different EEPROM size. Also sometime later, when I built and installed the CF flash board, I needed to make some more mods and add a boot ROM for it. Then when I added the VDIP1 board, I also needed to add a small daughter board. The VDIP1 board allows transferring files between an H89 running HDOS or CPM and a USB flash drive. These 2 add-on boards will be covered in future videos. I mentioned earlier repairing the damaged CRT mounts in the case. I disassembled and carefully removed the CRT, which first required removing the floppy drives. I then glued back the 2 broken CRT mounts on the case, first using super glue at the points where they broke off, and then reinforcing them using JB Weld epoxy around the mounts. I now had access to the video board below the CRT. I inspected it and performed the video board resistance and voltage checks outlined in the Heathkit manual, and they all looked good. I reattached the CRT to the front panel and performed the video adjustments as per the manual, which involves adjustments on the video board as well as the CRT yoke. The brightness is also adjusted using control at the back of the computer. The display looked good as far as brightness, focus, and position. Next up was the serial I/O board. It provides support for 3 serial ports, although only the parts for 2 were populated. I was referred to as serial test program H84 test that runs on HDOS or CPM for testing serial ports. It requires a loopback connector to be installed. I built the connector and ran the test, and it passed. I also obtained and installed the missing chips for the 3rd serial I/O port in case I wanted to use it at some point. Later, when I added the CF flash board, I removed the serial I/O board as the CF flash has 2 serial ports on board that provide the same functionality. The disk I/O board is Heath part number 85-2219-1. This is the H88-1 hard sector disk controller board, which requires hard sectored floppy disks. As mentioned in an earlier video, these are virtually impossible to obtain today, so in order to get the floppy drives working, I needed a solution. The board itself looked good. There was some insulating paper on the back that was coming off and warped, so I flattened it and reinstalled it with double-sided tape. To address the hard sector floppy issue, I decided to purchase a virtual sector generator or VSG kit. It sits between the floppy drive and controller board and allows using soft sector disks by adding the missing sector pulses. I'll cover this in more detail in a future video. The 2 floppy drives are Shugart model SA465 80-track double-sided drives. They looked in fair shape, although they may have been bumped around during shipping. There's a drive speed test built into the monitor ROM. Running the test showed that the drives were turning, although one seemed to be much slower. The speed test didn't show the correct speed. This was consistent with using soft sectored media when it expected hard sectored. Once I installed the virtual sector generator board, I did see the correct speed on one drive. The other drive was running slowly, but after a period of running the speed test, it sped up, presumably after loosening up the old lubrication, and it now showed the speed within specs. There should be terminating resistors on one of the floppy drives, but neither of the 2 had the resistor pack. My assumption is that it would have been on the 3rd external drive. I ordered a dip resistor pack and installed it on the 2nd rightmost drive. In order to run any floppy-based software, I still had a chicken and egg problem. As no floppy disks of software came with the computer, how could I generate a bootable disk without already having a disk operating system up and running? One solution is the H89 loader program written by Dwight Elvey. It allows you to transfer disk images between a PC and a Heathkit computer, communicating over a serial connection. You enter a very small bootstrap program into memory from the H89 monitor program, which then talks to the application running on a PC. The PC-based software runs on MS-DOS and not Windows, which can be problematic as most people no longer have MS-DOS on a computer. I found it ran fine under Linux using an MS-DOS emulator called DOSBox. With H89 Loader, I was able to enter the bootstrap program from the ROM monitor and write the initial boot program to the first track of a floppy. Once booted, the small program then talked to the PC-based H89 Loader program. However, I was unable to successfully transfer full disk images. After some discussion on the Heathkit Discord channel, it was concluded that the H89 Loader software assumed using 40-track disks and was not compatible with my 80-track double-sided drives. So I needed another solution. I was referred to the H89 CF flash board, which can act as multiple floppy drives under HDOS or CPM and even boot from it. Once booted from the CF flash board, you can format and write to real disks. Joe Travis on the Heathkit Discord channel sent me a blank H89 CF flash board, which I subsequently built up and got working. With it, I was able to boot HDOS or CPM from CF flash and then format and write to the floppy drives. I'm now able to boot from either floppy, but I generally tend to use the CF flash if it provides more storage and is faster and more convenient. I plan to cover this in more detail in a future video. The final board that came with the system was the mystery non-Heathkit board. The board itself just says Artra Inc. and H101A. A clue was the writing inside the system that referred to a Housemaster board. An internet search found some references to the product in some old Heathkit magazines. The Housemaster board from Artra Inc. was a peripheral board that supported home automation and other applications. It contains two AY3-8910 sound generator chips, a battery-backed real-time clock, two speaker outputs going to small speakers, and audio input and output connections. Advertisements stated that it supported applications for voice recognition, a real-time 24-hour clock calendar, stereo sound synthesis, a BSR X10 home control interface, and voice time control program. It originally came with a disk of 17 basic and assembly language programs, including Housemaster Home Control Program, provided along with a 90-page manual. It sold as a kit for US $399 or assembled and tested for $499. I plan to explore this further in the future. At the present time, no copies of the software or manual have been located. Once my system was up and running, I was able to explore HDOS, CPM, and many software applications. I'll cover these in future videos. As mentioned, I'll also discuss more on the CF Flash and VDIP1 boards that I built. On the hardware side, I still have a few things to investigate further. While the two floppy drives are working, I get some disk errors on one drive, and disks formatted in one drive can't be reliably read from the other. This indicates that one or both of the drives is probably out of alignment. I'd like to disassemble the drives, re-lubricate the bearings of the spindle and steppers, and perform an alignment. I also hope to explore the Housemaster board further. I may be able to track down a copy of the software or documentation, or write my own after reverse engineering the board.